In lesson 5 of chapter 5, we're going to work with operations with radicals. Now, this background is to help us with a future lesson when we do the quadratic formula coming up in a few lessons. So we'll give you some background, and hopefully for many of you this is a refresher course. So operations with radicals, square root. Now for background, we see if we square 5, we get 25. So we say 5 is the square root of 25. And we write it, the square root of 25 is 5. And then they give us the example of 9 squared is 81. The square root of 81 we write this way, and that equals 9. Now, there are a number of perfect squares. You're not expected to know all of them, but I'm assuming you would know some. The square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3, and so on. I would suggest in your notes you write a few of these just to refresh your mind and have a reference. Now we're going to do a little bit of vocabulary as we learn about radical signs. This is the radical sign as they indicate here, and you want to write that down to describe it. Now what is under the radical sign is called the radicand. Now we also have a little notch here that we'd like to add, that if there's no number in this notch, then there's a 2 there. Not having a number in the notch is a 2. Often we think of a 1, but no, there's no such thing as a 1 ever in that notch. It's a 2. And if there are higher numbers, as we'll get to the end of this, like 3, then that number has to appear there. Because without anything in that notch, it's a 2. Now, what goes in that notch, the 2, if it were there, we just don't write it, and the 3, this is called the index. So write this word down as part of our vocabulary. Okay. Now, another thing about radicals in general is that under the square root sign, you can't have a negative radicand. If it's a negative value, then that is not a real number. And we'll be reviewing some of these things as we go on. All right, some more vocabulary. And we can just write these out here. So when you take the square root of something, we think of its positive value as what is called the principal square root. Because if we had negative 2 squared, this also equals 4. If we have 2 squared, that equals 4. So normally when we just look at it and we're thinking of the positive value, in this case, that is the principal square root. We have to keep in mind that there's also a possibility that that could have been a negative 2 that we squared. Now, down below, they're repeating what we've just said. You can't have a negative 4 or any negative number under the radical sign. These are not real numbers. All right, let's go on. Now, for example 1, we can just write these out there right here. So if we are taking and evaluating square roots, 6 to the 2nd is 36. So the square root of 36 is 6. Now, if there's a negative sign in front of the radical, the square root of 36 is 6. Then you think of that as multiplying it by a -1 would make it a -6. All right, B, 11 squared is 121. So the square root of 121 is 11. And if you have a negative square root of 121, that is a -11. Now notice, we're not saying a negative 121 under the radical sign. This would be not a real number. Now if we square 0, we get 0. So 0 squared, or the square root of 0, is 0. And then in example D, the square root of any negative number is not a real number. So again, many of you would know this, but we want you to have it in your notes. Repetition. All right, let's go on. Now for example 2, write that down. A, if we square 4/5, we get 16/25. So if we take the square root of 16/25, we get 4/5. Now in example B, we've squared this, and they're asking us to take the square root of it. Now because of the negative sign in front of the radical sign, this will become a negative 0.03. Because if you squared 0.03, you get 0.0009. Again, I have some background. Now, for example 3, they're asking us to estimate square roots. So with a calculator, if you did the square root of 30, you get this approximation. And if you were to multiply these two numbers, that is, square this, it wouldn't quite be the square root of 30, because, again, this is irrational. And the decimal goes on. And no two numbers exactly are going, when you square them, will give you 30. And as we see here, 25 is less than 30, and 30 is less than 36. So here, this is the square root of 5. Of 25 is 5. This is the square root of 36 is 6. So you can see that this is between these two numbers. And here they're saying, even if you extend it, it doesn't quite get close to 30, but it gets close to it. All right. Now, for background information, simplifying square roots. So if we have the square root of a product, A times B, we can tease that product apart into the square root of A times the square root of B. This is the rule. And if you have a fraction, you can do the square root of the top, the numerator, and the square root of the bottom. So when we look at 144, the square root of that is 12. And if you teased apart 144, in a sense, that's the square root of 36 times the square root of 4. Square root of 36 is 6. Square root of 4 is 2. 6 times 2 is 12. So you see, we are allowed to do what we've described here, and the check proves that is, in fact, true. Now, if we move this up or down, depending how you look at it, we can also see that applies to fractions. Now, one of the things you'll be asked to do in the future is to take, let's say, the square root of 200. Now, you could put that in the calculator and get a value, but if they were asking you to simplify this, the protocol would be to see, and starting off by putting two radical signs, to see what's the greatest perfect square factor of 200 do you have. So if you weren't sure, you would go 200 divided by 2, and that's 100. And wait a minute, 100 is a perfect square. So under this radical sign, you would put 100. And under this radical sign, the part that's not a perfect square, that would be left over. And then the square root of 100 would be 10 times the square root of 2. Now, under the radical sign, there are no more perfect square factors. So you have simplified this. And this is what they're describing here. I did it in a shorter way. So as we do example 4, you're going to write that down. And you're asked to simplify the square root of 48. Now remember, the protocol is, you just put two radical signs, and what's the largest perfect square of 48? And you might say, I don't know that. So you're going to go 48 divided by 2, you get 24. Divide this by 2, you get 12. Divide this by 2, you get 6. Divide this by 2, you get 3. So here we have 1, 2, 3, 4 2's that make 16. So 16 is a perfect square, and what you're left with is 3. So this then becomes 4, the square root of 3. You have simplified this. Now for 63, you might say, what are the factors of 63? You might know that that is 9 times 7, and 9 is a perfect square. So this becomes 3, the square root of 7. Now notice that in part C, you're asked to simplify this, and you could treat it separately. Now 16 is a perfect square, so this is going to become 4. And 75 is 25 times 3. The square root of 25 is 5, the square root of 3. So you have simplified each of these. And again, there is no perfect square factor under the radical sign. We're getting into a little more background information, which is the addition and subtraction of radicals. Now you can think of a radical as if it were a variable, and when we added like terms, as long as our variables are the same, up here we could just collect the coefficients. Well, this applies to radicals. As long as they're the same, we can deal with the coefficient part. So you have 2 of these, 3 of these, this is 5 of these. You're going to take away 8 of these. This leaves you with a -3, the square root of 5. Now when you have something like this, the radicals are not the same. You can't combine them. Now below they're showing what you could do when the radicals are not the same. You could simplify them to see if you could put them into a form that you could join together. So let's just follow this. Now, the square root of 12 is the square root of 4 times the square root of 3. Now, the square root of 4 is 2, the square root of 3. So you're going to multiply the 2 times 4 and get 8, the square root of 3, for that first term here. Now, 75 we knew was 25 times 3. The square root of 25 is 5, the square root of 3. So we have now two radicals that are the same. And then 108 is the square root of 36 times 3. Square root of 36 is 6, the square root of 3. So now they all have the same radical sign. You're going to group these two and get 13. 13 minus 7 is 7, the square root of 3. Again, we have a lot to cover, and we're getting to the more challenging items here, but hopefully you're following what we're doing here. We'll be doing some practice and some certify as part of our lessons. Here's an example. In fact, let me write this one out, and you'll put this in your notes. 5, and then the square root of 32 plus the square root of 18. We're going to see if we can combine some like terms here. Well, the square root of 32, if I divide that by 2, I get the square root of 16 times the square root of 2. And then here I get the square root of 9 times the square root of 2. Square root of 16 is 4, the square root of 2, plus 3, the square root of 2. Now I can combine and get 7, the square root of 2. And let's do the next one also. As an example, and I'll write it out, the square root of 12 plus the square root of 18 plus the square root of 27. And we'll go to our whiteboard. Now, the square root of 12 we've done already. That's the square root of 4 times the square root of 3. This is going to be plus the square root of 9 times the square root of 2. And this is the square root of 9 times the square root of 3. So here, square root of 4 is 2, the square root of 3, plus 3, the square root of 2, plus 3, the square root of 3. Well, we have two like terms. This is not like. So we can group these together and get 5 plus, or 2 plus 3 is 5, the square root of 3, plus 3, the square root of 2. Again, some background. We'll be using this in the quadratic formula that we're getting to in a little while. All right, going back to our regular and going down, we can see what they ended up with here. And square root of 5, the square root of 3, plus 3, the square root of 2. Now they have one other, and perhaps we can just take it right from here to save time. So the square root of 5. Now 20 is the square root of 4 times the square root of 5. And I guess that's as far as they're going. So square root of 4 is 2. And this would be this 1, the square root of 5, minus 2, the square root of 5. And then 1 minus 2 gives us a negative 1 that we don't write the square root of 5. All right, we'll again pause if you need a little more time. We're moving along a little bit quickly. We'll skip example 6. Going on now to example 7. We're going to work these out. Again, 7. The square root of 3 times the square root of 7 is the square root of 21. And there are no perfect square factors. Now, when we do this multiplication, and we might think of it as this way, square root of 5 times, now if we tease this apart, this is going to be the square root of 5 times the square root of 3. 5 times 3 is 25. But now we have, can you see here, the square root of 25 times the square root of 3. So the square root of 25 now is 5, the square root of 3 for this one. Now, here we're going to multiply. 2 times 2 is 4, and then we get the square root of 60. Now, is there a perfect square within the 60? And the answer is yes. That would be 4, the square root of 4 times the square root of 15. So the square root of 4 is 2, so this becomes 4 times 2, the square root of 15, which is 8, the square root of 15. And that's what they're showing down here. Now, as we go into example 8, we're going to multiply radicals. And this is example A that I'll do on the whiteboard here for you. So here we use the distributive principle. Square root of 7 times the square root of 7 is the square root of 49. The square root of 49 is 7. So I'm simplifying that. Now, keep in mind that as we times this times that, we're going to get a negative square root of 7, this one, times 7, breaking that up into 7 times 2. So we can separate that a little bit. This 7 times 7 is going to be the square root of 49. So rewriting that, I know it's a little complicated. The square root of 49 is going to be 7, the square root of 2. So we've distributed this, and square root of 7 times the square root of 7 is square root of 49 is 7. And I tease this into 7 times 2. When I added this, I ended up with 2 7s that made this a 49. Took the square root of that, got my 7, watching the negative sign, the square root of 2. So as we go back from the whiteboard, we'll see that's what they have for this answer. And that was the protocol they did. All right, now let's do example B for your notes. And I'll write it up here. This is, we're going to FOIL here. Square root of 2 plus 5 times the square root of 2 minus 5. Now, these are what they call radical conjugates. So going to our whiteboard, since they are conjugates, the middle terms cancel out. Now, the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. And this is going to be a negative 25. And then we do our summation here. This is a negative 23. And let's take a look at it down here. We have to move this down a little bit. And there it is, negative 23. Again, we're learning a few things here that we may not be using in our course. This is something new. We haven't done this in the 1108 before, and I'm not sure it's going to be here, but since it's in this lesson, we'll go along with it, take some notes. We will officially skip number 9 for the sake of time. And I believe we have one more topic to do. And from my old high school days of algebra, this was something I always thought was so named so well. And that is rationalizing the denominator. Now you'll notice as we look at these three terms that there's a radical here in the denominator. There's a radical there, and there's a radical there. Generally speaking, when you are simplifying terms, you do not want a radical left in the denominator. So we go through a process of rationalizing a denominator. Okay, that's what we're going to show you and work it out. So for our last example, example 10, we're going to do A, B, and C on the whiteboard so you can follow it step by step. And I'll change colors so we can see what's going on. Now, the protocol for doing these is we have to multiply these fractions by 1, so it doesn't change its value, but we can choose any form of 1 to make our denominator rational. So often we just say, well, what's the square root of 3 here that would make this a perfect square? Well, if we multiply it by 1 in the form of the square root of 3 over the square root of 3, this now becomes 5, the square root of 3 in the numerator, and we get the square root of 3 times the square root of 3 is 9, square root of 9, which is 3. So we have rationalized this denominator. Now over here, what form of 1 are we going to use to rationalize the square root of 2? This is sort of a hint. If you said you're going to multiply both by the square root of 2, that is correct. So our numerator now becomes 3, the square root of 2. Now this becomes square root of 2 times the square root of 2 is the square root of 4, which is 2 now. 2 times 7 is 14. Now if this were 2, we could do some cross-canceling, but it's not, so we leave it that way. Now this one's a little bit tricky, because you might say, well, it's going to be 8, square root of 8. No, because this is actually the square root of 7 over square root of 4 times the square root of 2. Now the square root of 4, we've done this before, is 2, the square root of 2. So I'm simplifying this already. So now what do we multiply this by to get rid of the square root of 2? Well, the same thing we had over here. Square root of 2 over the square root of 2. So now my numerator here becomes the square root of 14. This is the square root of 2 times the square root of 2, which is the square root of 4, which is 2 times 2 gives us 4. And let's check it out here as our solutions. And let's see if what's going on. There we go. And we'll bring that down a little bit here. And there we see all the answers. Okay, well, this wraps us up. We ran, again, a little long, but there was a lot of stuff here. And again, as background and needing this material, again, our name of our course is Preparing for College Math. And in the later courses that you take, you'll be doing some of this. So a little review.